Hi, my name is Alexander. Welcome back to my channel. This is the first video about authentication and authorization in Angular application. Authentication is the process matching the visitor of a web application with a predefined set of user identity in the system. It is a process of recognizing the user's identity. Authorization is the process of giving permission to the user to access certain resource in the system. Only the authenticated user can be authorized to access a resource. Let's start. I have created a standalone project, Angular 18s, using Angular version 18. It is almost the same project that I have created in my previous video, Angular and NGRX state management, but now it is standalone project and without state management. Starting with Angular version 14, they introduced standalone components, allowing users to build applications without the need for modules. Starting in Angular version 17, new projects are standalone by default. The project contains 4 standalone components under the folder Superstore. Products, which is used to get the whole products list from the SQL Server database. Computers, which is used to get the products list from computers department. Cars, which is used to get the product list from the cars department. Cafeteria, which is used to get the product list from cafeterias department. In application component, we use router navigate to load products, computers, cars, cafeteria components by button click. In app routes, we use lazy loading for each component. It means that Angular application doesn't load all components when application starts and will load every component by the user request. On the server side, I have used the project which I have created in my previous video, Angular and NGRX state management. I can remind you briefly that the project is RESTful API with .NET Core, which in turn communicates with the SQL Server using Entity Framework. The following NuGet packages have been installed. Microsoft Entity Framework Core SQL Server, Microsoft Entity Framework Core Tools, and NewtonSoft.json. Swashbuckle.ASP.NET Core has been installed by default. The product controller class contains the following asynchronous public methods. GetProductList to get the whole product list from the products table. GetProductTypes to get the departments from the product type table. GetProduct to get the requested product by product ID. AddProduct to add new product to the products table. DeleteProduct to delete product from the products table. And the private method setProduct. The method is used to restore the product object on the server side from the stringified product object which we sent from the client to server in HTTP request. Let's start server-side application. Application uses port 7068. Check the port in a client-side application under the class product base. It is 7009. Let's correct it to 7068. Compile and start client-side application. Get products, computers, cars, cafeteria. Get product by product ID. Add product. Delete product. Everything works, but now user can use application without authentication and authorization. Let's implement authentication. Create 2 new components, login component and content component. To the content component, we will transfer all the logic that currently exist on app component. It is a logic to communicate between the components and server-side RESTful API. Login form will be used to log in or register a new user. After successful login, user will be redirected to the content component. Transfer code with some changes from app component to content component. Copy and paste the code from app-component.html and app-component.ts files to the content component.html and content component.ts. Add content roles.ts file. Add login roles.ts. Make changes in app component. Update app roles.ts. Now application component contains only link to login component. Compile application and test. Open terminal. Click login. Login component is loaded. Let's create a login and registration forms in a login component. To expedite the process, I used CodePen site to pick up a login form. CodePen, it is open source social development environment for front-end designers and developers. The site contains a lot of code samples. I picked up this form for login and registration. Let's copy only HTML code to our login.component.html file and CSS code to login.component.css file. Compile application and test. With the help of CodePen site, we could quickly create login and registration forms. Now we will convert HTML forms to Angular reactive forms. Reactive forms provide a model-driven approach to handling form inputs whose values change over time. Angular provides a powerful and comprehensive form module that enables you to create interactive and validated forms. Reactive forms can be used after importing the reactive forms module into our project. Also, reactive forms provide several built-in validators that are required to validate the forms. Implement our code with built-in validators. And login components.ts. We implement login on click and register on click to switch between login and register forms, and implemented ng-class directive that adds and removes CSS classes on an HTML element by condition. It applies blue color to the button of active form and gray color to the button of inactive form. A form group aggregates the values of each child form control into one object, with each control name and the key. It calculates its status by reducing the status values of each children. For example, if one of the controls in a group is invalid, the entire group becomes invalid. Compile and test our application. We can switch between login and registration forms, and we implemented built-in validators, required email and min length. The valid property of a form control or form group indicates whether the control or group has passed all its validations. It becomes true if all validations pass. Conversely, the invalid property indicates whether the control or group has failed any of its validations. We can use invalid and touched property of the form control to indicate all validation errors of the form control. To implement additional rules for validation, we have to create a custom validators. Let's create email validator and password validator under the folder app common validators. Fortunately, the samples of custom validators for the password and email have been created already, and we can just copy its code. For example, the custom validator for password exists on the site blog.angularuniversity.io. Let's copy and paste this code with some updates into password strange validator. Similarly, for example, from stackblitz.com site, we can copy regular expression pattern for email validation. Copy email regular expression for email validator and add our code. Add new file and copy regex expression with our code. In reactive forms, validators are indicated in a validators array for every form control. In our case, we have two form controls for email and for password. Add our validators to validation array for each component. For the confirm password control, we have created match password validator. The form field validator function, returned by the validator creation function, needs to follow these rules. Only one input argument is expected, which is of type abstract control. The validator function can obtain the value to be validated via the control value property. The validator function needs to return null if no errors were found in the field value, meaning that the value is valid. If any validation errors are found, the function needs to return an object of type validation errors. The validation error object can have as properties the multiple errors found, usually just one, and as values the details about each error. The value of the validation errors object can be an object with any properties that we want, allowing us to provide a lot of useful information about the error if needed. We just want to indicate that error occurred without providing further details. Therefore, we simply return true as a value of the error property in the validation object. Add the conditions for the custom validator's errors to the form controls in the login components view. Test project. We can see that validators work. Now we have to create requests to the server side for the user registration and login. Open SQL Server. We have to create a table to store users' credentials. Add users table to the store database. User table contains the columns email, password, salt, created date. Also, I have created two additional fields, refresh token and refresh token expire time. These fields we will use in the next video, where we will add JSON Web Token and refresh token to Angular Authentication and Authorization processes. After adding a new table into the database, we have to update dbContext using scaffold dbContext command. My suggestion: don't make change in the code, like using a new table before executing scaffold dbContext command. To avoid scaffold command crashing, rebuild a solution first to make sure that the solution build is successful. The build is successful. Open NuGet Package Manager console and execute scaffold dbContext command. Command executed successfully and added user.cs class to the models folder. Add login and registration methods to a product's controller class. Add methods hash password and verify password. Add properties for hashing password. To be registered, user has to provide credentials, email and password. Registration method encrypts password and saves user's credentials, email and encrypted password in a database. To encrypt the password, I use the hashing algorithm described in this article. C# hashing certain passwords, best practices. I will show the code in the registration method and will quote this article. Hashing a password means applying one-way encryption algorithm that will produce a cryptographic string. One-way encryption cannot be decrypted, making it impossible to infer the original password from the hashed string. By storing a hashing version of password, we ensure that user credentials will still be safe in case of data breach. Attackers won't be able to decrypt hashes to obtain original passwords. Unfortunately, hashing is not enough to keep passwords safe from bad actors. One downside of the hashing algorithm is that they always produce the same hash given the same password. Unfortunately, hashing is not enough to keep passwords safe from bad actors. One downside of the hashing algorithm is that they always produce the same hash given the same password. Meaning that once a single password hash has been compromised, it might very well be that more than one user is affected because they decided to use the same password. To avoid this, we must salt our passwords before storing them. Salting is the process in which we add a random piece of information to the password before hashing, making every password hash unique. This will render brute force attacks much more difficult. To generate our password salt, we use a cryptographic random number generator, such as random number generator in the system security cryptography package. We define the key size constant as 64. It is the desired size in bytes of the resulting hash and the size of the random salt. Hash password function takes a password in a clear text and returns its hashed version. We obtain the random salt generated along the process via the salt output parameter. It is important to get and store this piece of salt since it is necessary for later password verification. We use this static method in system security cryptography package. The method takes several parameters including a salt. pbkdf2 can be applied multiple times to a given input value to strengthen the resulting hash, so we define the iterations constant. Reportedly, safe version for the production environment are in hundreds of thousands. Therefore, we have defined iterations as 350,000. Finally, in the hash algorithm variable, we define the underlying hashing methods pbkdf2, which use for derivation SHA512 in this case. Hashed salt and hashed password we will add to password and salt property of the user module class. Finally, we will save hashed salt and hashed password in a database table users. Once our user password is securely stored, the other important flow to consider is the verification of user passwords when they attempt to log in to the system. Since we cannot decrypt hash algorithm, we must hash the incoming password again and compare the result with the hashed version we originally stored for the user. The correct password will always have the same hash. We implemented this in the method verifyPassword and use this method in a login method. Both methods, login and registration, uses the same user credentials, email and password. Try to build a solution. The solution compiled successfully. Let's go to a client-side code and implement the requests to the registration and login methods. Add user as service. Add user class to a superstore types folder. Implement onSubmitLogin and onSubmitRegister methods in login component. Import addService. Inject addService. Import user. Add onSubmitLogin and onSubmitRegister methods. Bind ngSubmit element in the login and register forms to a callback functions onSubmitLogin and onSubmitRegister. Add roles to content component in login.roles.ts. When we copied the code from application component to a content component, we added suffix login content in front of each navigation roles because navigate function requires full URL path. Start server and client-side applications. Try to log in any not registered user. We see an error. User with email alex@canada.com doesn't exist. Please register user. Just to test validator, let's put a wrong password into confirm password input field. We have a notification passwords do not match. User registered. Check the table user in SQL Server database. We see that record contains user's email, hashed password and salt, and date time when the user has been registered. Try to log in. We can log in successfully and can use application logic to receive and send data between client-side and SQL Server database. Get product, add product, delete product. Everything works. But one problem still exists. If users know URL to any component which can interact with database, they can communicate with database as well. For example, copy current URL to a different browser to simulate user activity on any other computer. We see that user can interact with database without authentication process. This problem will be solved in the next video by implementing access token and refresh token. That's it what I wanted to show you in this video. See you in my next video, Angular Authentication and Authorization Part 2, where we will implement JSON Web Token, Interceptor, and Refresh Token. Thank you for watching. Please subscribe to my channel and have a good day. Bye.